Hello and welcome to another tutorial. We are going to continue our discussion on how to run a Java application and then look at what is the difference between running your Java application on the JVM. Basically, you launch the JVM or the Java command line tool, and then you tell it where your class file that contains the main method is, and then what happens when we actually compile our Java application to a native binary using the native image tool that comes with the GraalVM. All right. So in the previous lecture, we saw that basically organizing your Java application, and let me bring up the terminal. We saw that organizing your Java application, obviously you don't want all the Java files to be in the same directory. Sometimes you have multiple directories, and then also sometimes you want them to belong to some package, right? Just because if you're creating a library, you want to put your class files, you make them belong to packages so that later on somebody else can add them to their basically class path and be able to use those codes that already exist in their application too. But then the problem was that compiling and running the Java application is not a trivial task because of the way that Java compiler and the JVM, which is the Java command line, handle the dependencies of your classes. And we saw that if I have a hello world class and a car class, and each one is defined in its own Java source file, and then if they're in two different directories, and we saw that in this example for simplicity we didn't make these classes to belong to any packages, and basically the idea was that I couldn't just directly compile the hello world because it had a dependency on the car. So I had to first tell the Java compiler to compile the car.java to create the car.class. Because when I run the Java compiler on the hello world.java, it realizes that there is a dependency, and then it needs to ensure that Java always tries to be on the safe side and ensure that if it's trying to compile this class, there shouldn't be any error, which means all the dependencies, all other types that this class use have to be known to the compiler. The compiler has to ensure that at compile time, the other class files that are associated with these types, such as car in this case, already exist on the hard disk, right? So we had to specify the -cp or -classpath, right? This classpath parameter, and this here we list all the directories that the Java compiler or the JVM can search into. And we said this is very similar to the path environment variable that the operating system and the terminal understand, right? It's very similar. Path is an environment variable that has a list of directories, so that when you type some name, the terminal assumes that this is some sort of executable binary application. So it tries to search into all the directories that are included in the path to see where it can find an application with this name, right? And we said that in Java, you cannot tell it Java and then the full path or the relative path to the class file. That doesn't work. Instead, you have to tell JVM this -cp parameter and give it a list of directories that the JVM can search into to find all the class files that it needs to run your Java application, right? So the concept of class path is very important. And then basically there is another thing that we can do, and that's I mentioned that you can define something called the class path environment variable, and if you define it in your terminal when you launch your JVM, then basically you don't really need to specify that CP. So what I mean by that, right now I'm in the test directory, right? So if I say Java and then hello world, I've already compiled this, right? It's not going to work because it cannot find this car.class, right? So I have to tell it Java -cp and then the current directory where my hello world class is, and then colon, which is a class path separator, and I'm going to tell it go to one level up and then go into the test2 directory. So I'm specifying two directories on my class path when I launch my application that have this that have all my class files that the application needs. And then I tell it launch the hello world class, which means JVM launches or runs the main method of this particular class. And this works, right? Now, so if I don't specify the class path, I get an exception, right? So the application terminates unexpectedly just because it cannot find this car class, right? But then what I can do is I can basically open up a text file, right? And then I'm gonna open some directory. I'm going to go and then open up this bash rc. So this is where you can define the environment variables, right, that for your terminal. So I'm going to define another one, or a classpath environment variable. Now when you globally define these classpath environment variable for your terminal, every time you launch the terminal, those directories that the class path is pointing to are already available to JVM. So we say export class path equals, right? And then we give it a list of directories, and then the separator is colon. So we can say, for example, I'm going to give it the absolute path. So I'm going to copy the full path to the clipboard and then go back here and put it here. All right. Now what this does is this is basically the full path to this test2, right? Now I can also append this dot and then give it another path. And what you can do, basically export class path again. But here what we're going to say that we're going to give it this test, also the fully qualified name of this test, right? I'm going to put it in double quote. If your name, the folder name has a space or something, you have to put it inside double quotes. But then I'm going to append it with the original class path variable. So this appends, so the class path separator is colon. It reads when you use $sign, it means it's an environment variable and it's reading the value. The original value is test2, and now the test directory is also appended, right? So if I save this and then go back to my terminal, what I'm going to do, either you have to restart the terminal or use a command called source that reload this bash rc file. So I'm going to say that source from home directory, load the bash rc file again. Let's see, and everything is successful. And then if I try to read this basically class path environment variable, echo class path, you see there are two directories on my class path. All right, now let's go out. So I'm going to let's even go to the desktop, right? From home direct, I'm on my desktop, right? And then what I'm going to do, I'm going to say Java hello world. Let's see if it's successful in running this or not. And as you can see, it's fully successful, despite the fact that I'm not even in any of these test or test2 directories. I'm in my desktop. But when I told JVM to find a class file called hello-world.class and execute its main method, it had no problem, because Java behind the scenes, it tries to see if there is a global environment variable for your operating system called the class path. If it finds one, it also includes all the directories that are defined by the class path to your class path variable. So I can still specify -cp something like current directory, right? And then say hello world, and this doesn't work. When you explicitly basically provide this -cp for the JVM, it overrides, it doesn't look for the class path environment variable again. So what you can do is say for example current directory colon and then that class path environment variable and then hello world, right? So basically, so what happens here is that the problem with this is that I guess we should put this in double quote or do something else. Let's see if this works. Double quote, and now it works. So that's because there are forward slashes and other things. So put these environment variables, if you want to read the value, put them in double quote so that there is no problem. So basically this, if there are some dependencies for your classes, let's say there are some libraries that you always use, it's better to define the directories that contain those libraries as a class path, as an environment variable, so that whatever application and you write, you compile, those directories are available to your Java application, right? So if, for example, if I let's say if I create a new directory, let's say test3, and here I'm going to create a class file, right? And let's rename these to something else. Let's say instead of car, let's say machine. Okay, and let's open it. And here we have to rename it to machine, because if there is a public class definition in the source file, the name has to match. And then we're going to say that a string type, and then we're going to pass the string here, and then we're going to, obviously the name of the constructor should also be machine, and we're going to say that machine, and then type equals %s, and then this is going to be type. All right, and then we go back to the hello world, and then we create a car, then we create also a machine, new machine, type is printer, for example, and then we're saying that system.out.println machine. All right, now going back here, right now I am in my desktop directory. So what I'm going to do, I'm going to go back to the bash rc, and then try to export, basically do the same thing. I'm going to go back here, classpath equals, and I'm going to basically append the test3 to my classpath. All right, now I am going to source the bash rc again to reload this environment variable. So if I say echo classpath, now there are 3 directories on my classpath, right? Test3, and then let's see. So we have test2, and then test. Okay, so let's see. So I'm going to, let's close this. All right, and then reload a new window, and echo classpath, and now we have test3, test, and test2, right? So there are 3 directories, and I can say java c, and then directly compile that hello world.java. So file not for, obviously here you have to specify the full path to that basically hello world.java. So let's right click on this, and then copy full path to clipboard, and then go back to the terminal, and then we are going to compile this. And note that I'm not specifying the I didn't specify this machine, it's not there, but because java c also looks at an environment variable called classpath, and if your class file, if your Java source for hello world depends on a dependency like machine.class, Java C also looks at those directories that are included in the environment variable to see if it can find a file called machine.class. And now I can even execute it, hello world. Now note the difference. When you compile a file, you have to give it a path where it is on the operating system. When you launch a Java application, you have to tell JVM the name of the class file that has the main method. You don't specify the path to that class file, right? You just tell it the name. And JVM fully relies on the class path, all the directories on the class path, and it tries to search into them. So this works. Why? Because I didn't specify any class path. I'm not even in the test directory. I'm somewhere else. But when I launch it in terminal, the classpath environment variable is defined. All right, and therefore what happens here is that JVM just searches into all the 3 directories and tries to find a class file called hello world. All right, so again, for when you launch your Java application, you don't provide the full name of the file hello world.class. That's not how it works, right? You just provide the name of the class file, or the name of the type. If it belongs to a package, you have to also specify the package hierarchy here, the type or the class that has the main method. And JVM only searches into the directories that are specified on the class path. Now you can manually specify the class path directories using -cp command line argument, or you can define them globally in a variable in an environment variable called classpath, right? And you can append multiple directories using the colon, which is the class path separator. So I hope you understand this. Now what I want to show you is the concept of native image. So let's go back here. So copy fully qualified name. Let's change the directory into that. All right. And then so right now what we want to do, let's see if we can basically compile this hello world class to the native binary. So I have installed the GraalVM basically native image. I will show you in the future lectures how to do it, right? And then what I'm going to do, I'm going to tell it compile test. It's in the test, and then basically what do we want to compile? Hello world. Let's see if this works. Actually, I think the class path is already defined, so what we want to do, we just want to compile the hello world. I believe it will be able to find the okay, hello world not found. So let's see, test hello world not found, so it's still not able to find it. So what we can do, we can specify basically, I guess, the same class path argument. So -cp class path, all right, and then hello world. Now it's working, which means what it does, it searches into all the directories that are specified in this environment variable, and it is able to find a class file called hello world.class, and it starts to compiling it to the native binary. Obviously this class has dependencies, car on machine, and both of them are specified in the class path. So the native image has no problem finding them and also compiling them to the native binary. What it does eventually, it creates a native image. Now the compilation succeeded, and it says that I created a executable binary, which is hello world, and you see it's here. All right, now let's see if we can execute it. So the execution of the native binaries applications in terminal are different from JVM, right? When you launch the Java, you cannot give the path to the file. You have to specify the directories in the class path. Whereas when you want to execute a native binary, you provide the full path. So I'm in the Java native image. So from the current directory, hello world. And this is a fully executable file. It's a binary application. It doesn't rely on any JVM. It doesn't anything. It's fully there, and it works pretty well, right? So we compiled our Java application into a native binary. So this hello world is a native binary. I can give the full qualified name of this file, right? So this is the basically the path, the directory hierarchy to the name of the executable. And in terminal, when this works, you can always execute a native binary by providing either a relative path to it or a full path to it. If I execute it, it still works fine. Hello world from Java application, but this is not, we're not launching JVM. We just compiled our application directly to a native binary. All right. And now it works fine. It gives us the output that we expect. And right now, the way we compiled our application was to rely on this class path, which is globally defined, and the native image had no problem finding our class files, hello world, and all the dependencies that it has, which is car.class and machine.class. Obviously, for large programs, it's not recommended to basically rely on this environment variable, because you have to manually add them. So there are better ways to manage them, but in the terminal, if there are some dependencies that you always use for all your Java application, it's best to also define them as a global variable called classpath. And the point here was to show you that you can define this classpath environment variable, and the Java C and Java or the JVM, they will also try to search for a variable called classpath that is defined or known to your terminal. All right. So I just showed you an example, a quick example of what a native image is. You write your application in Java using a Java IDE. It saves you a lot of time for developing a big application. Know that what we're comparing to, we're comparing developing a Java application to a C++ application, because once you compile your application to a native binary, you essentially are equivalent. You're getting an equivalent to a C++ application that is compiled to native binary. Launching this is instantaneous. There is no JVM, there is no loading any JDK class files into memory, nothing. Now the main difference, you will see that the size of this native binary from Java is much larger than if you write an equivalent C++ application. The file size, if you write this application that prints something to the console, it's just a hello world, some objects. In C++, the final file, which is executable, it's going to be like a couple of kilobytes. But here, this hello world is probably around, we can look at the properties. So it's around 11 megabytes. And most of this size comes from compiling the JDK classes. Remember, your application depends on them. So the native image compiler has to compile also all of them, right? So this 11 megabyte, essentially a compiled version of all the classes that come with the JDK. And your application is probably just a few kilobytes that gets added to that 11 megabyte, all right? But again, the benefit is that this launches instantaneously, and you pretty much get the optimized version, because the native binary has a static compiler that does a lot of static optimization. So you get more or less equivalent to a C++ optimized compilation. So now that you've seen the example of native image, I'm going to give you more details of what this is. So the job of the operating system is to manage the applications running on your computer. Every time you double click on an executable file, it gets executed. Every time you type the name of an executable file, right? This hello world in executable file. And when you hit enter, the operating system realizes that this is an executable file. So basically, if I do ls-a and then let's see. So you see this hello world is red and has an asterisk. This means this is an executable file, which means if you just type the name and hit enter, the operating system is able to execute it and give you the feedback, which are the output of the application, right? The other ones that end with a slash, these are directories, right? If I say hyphen, basically ls-l, which means a long version of the listing, this hello world comes out as X. So X means it's an executable file. All right. And we will look at these attributes later on, but for now, we're just looking at the native image, compiles your application to the Java application to a native binary. Developing a Java application is much faster. Java has a much nicer API, much easier to do. And then when you combine that fact with the fact that we have very, very capable IDEs, you see that a native image gives us a lot of benefit. So what is a compiled application? A file containing binaries. And these files have just the instructions for the CPU. These are directly tied to the architecture of the CPU you're using. For example, if you're using an AMD CPU, 32-bit, 64-bit, if you're using a ARM CPU, these are different. So the binaries are not compatible because the CPU instruction sets are not compatible. And instruction set for the CPU is just a machine code. And usually machine code is just zeros and ones, which we humans don't understand. So a one level higher than machine code is assembly code, which is very simplified instruction sets. Humans understand that, right? Assembly code is human readable. But then again, one level above assembly code are like C++ or C codes, right? And the compiler compiles them to assembly, and then an assembler application, right? Compiles the assembly code into machine code. So binary files can be directly run if they have executable permission. And when you compile your Java application with the native image, we see that when you do ls, which lists all the files with a -l, it tells you that this hello world is executable. It has an asterisk, and it has the executable permissions. And we will look at these permissions later. Usually you have 3 groups of permissions. The owner, which in this case is me, is me, the group, and then everybody else. So right now this application has the I'm the owner of this file, and I have the permission to execute it. So the three first letters means I can write to this file, read to this file. X means execute. So executable permissions mean I can just say hello world, type the name, and the terminal and operating system will execute it for me. Now I can change the permission, the executable permission. So chmod means change the mod or the mode that this file is. And I can say -x and then hello world. So what this does, if I do ls-l, as you can see now, this hello world doesn't have an asterisk anymore, which means this doesn't have the executable permission anymore. If you look at it, the third character was X, but now that X is gone for everybody, right? So if the owner removes the executable permission, everybody else also loses that. What this means is if I just type hello world, it says the file hello world is not executable by this user, right? I manually remove the permission for executing that, but I can bring it back by saying that chmod. So let's go back. Chmod, instead of saying -x, which means remove the x attribute, plus x, add the executable attribute. All right. And now if I say ls-l, now this binary has the permission. So you can have a binary that has the instructions for the CPU, but obviously the operating system is the guard between the applications and the hardware, right? Operating system has to make sure that if somebody tries to execute a file, that file has the permissions, right? Permissions. Otherwise, it's an illegal operation, right? To the operating system. So there are checks and bounds so that the operating system ensures that it's not a malicious application. So if I say hello world, now I am able to run this binary again. So file permissions, it's separate from whether the file is basically a binary executable or not. The nature of this hello world is an executable binary, but you can only execute it if you have the if the file has executable permissions, right? Now, for example, this text file, it's a text file, right? It is not executable. If you look at this, you see it doesn't have an executable or X attribute just because it's not really executable. You cannot execute this. You can open it and read the characters from it, but it doesn't have instructions for the CPU. Whenever you have an executable, it has really zeros and ones that the CPU understands, but a text file has zeros and ones that the operating system understands, right? So the text file only character encoding. So if you look at it, these characters are UTF-8. Each character is encoded in 8 bits or 1 byte. This is not something that the CPU understands, but it's the operating system that understands it. So when you double click on this and open it, operating system realizes that there are zeros and ones, and because it's a text file, then it knows how to correctly translate those zeros and ones to a format that the humans understand, right? So there's a difference between binaries, which have instructions for the CPU, and for example, text files. They don't have instructions for the CPU. Those are just character encoding. The zeros and ones in a text file are something that the operating system understands, not the CPU. So binary files can be run if they have executable permission. On macOS or Linux, you write chmod, which means change the mode of operation of this file. +x means add the executable attribute. -x means remove the executable attribute. On macOS and Linux, executable files don't have any extension. Right now, when we compile our application here, hello world, it doesn't have any extension. It's just executable, right? Extensions are extra information for the operating system. If a file is executable binary, there is no instruction for the operating system. You just tell the operating system, hey, this is executable, and execute it, which means this file only has instructions for the CPU, right? A text file has instructions or extra information for the operating system so that it knows that how to display the contents correctly. But the executable file, it doesn't have, you cannot display it as characters, for example, because it's just zeros and ones that the CPU understands. On Windows, executable files have .exe permission, right? So Windows is always a little bit different from macOS and Linux. Platform tool chains. As you saw in my quick example of the native image, you have to use a compiler to compile some application to, or basically some source file into a executable binaries that CPU understands. C++ is very easy. They always have a strong compilers that understand the C++ source code. For Java, we had a two-step process. One, use the Java compiler to compile the Java source code to Java binaries that the JVM understand. And then on top of that, after that, we use the native image compiler that understands the class files and produces a native executable binary. So eventually you have to need some sort of compiler and feed your files, source files, or in this case class files from Java to that compiler, and then it understands how to translate it to the instructions that the CPU understands. And obviously compilers are optimized, or they optimize your source file, source code, which means they can provide some levels of static analysis and static basically optimization. Compilers that compile source code to binary for CPU. Every platform, which means every operating system in this case, they come with their own compilers, because every operating system has a different API that allows the user to talk to the hardware. I mean, hardware could be the same, but different operating systems use different APIs. The functions they use, the conventions they use, they're different. That's why when you compile to binary for different operating systems, you have to compile on those operating systems, right? Or use the compilers that are specific to that operating system. macOS, developed by Apple, they provide their own compilers, which is Xcode, right? Xcode is the tool. You can basically, it's a general application, provides a nice interface. You can type your code and compile it. But if you want to judge just the compiler, you can use command line tools. You can type you can just install the Xcode application from the app store, and then it automatically also installs all the toolchain, all the compilers, and the dependencies that those have. So Xcode on macOS, that's the easiest way to get all the platform tool chains that you need. And when you do that, let's open up a terminal here. On macOS, when you install the Xcode, it creates some aliases on the terminal for the compiler. So if I type G++ -version, it's pointing to the Apple Clang. So it's a Clang, but it has an alias G++. If I say Clang -version, it's pointing to the Clang again. If I say C++ -version, it's pointing to the same thing, right? All these aliases are created so that you can use that, right? So even GCC -version, if you want to compile a C instead of C++, it's going to basically I mean, these days we just use again, it's also pointing to the Apple Clang. So when the easiest way on macOS is just install the Xcode, and then the tool chain is Apple Clang. So it's based on Clang. It's not based on, for example, the GCC or GNU. And this is a proprietary compiler, so you cannot, it's not open source. You cannot download it for free unless you are using a macOS. There are, for example, Linux obviously is open source, so there are open source compilers, GCC, GNU compiler collection. You can even download and install GCC on Windows, for example. They also provide that. And on Linux, you also have the option for Clang. Same for Windows, you also have the option for Clang. And these are open source, free to use. On Windows, when you install it, usually when you install Linux, it always comes by default with the GCC. macOS, you need to install Xcode, but it's a very easy installation. You don't really need to do anything. Windows by default doesn't come with any tool chain. The options, one of them obviously is provided by the Microsoft itself, which is MSVC, Microsoft Visual C compiler. And in these lectures, I'm going to show you how to install this. This is the recommended way for working with the native image in Windows, but there are also other options like GCC, Clang. These are open source. MSVC is not open source, so it's also proprietary. And why use native image? Because a compiled binary, which is pretty much ready to execute for the Java application, it has a very fast startup time. All the JDK classes have already been compiled, There is nothing, we don't launch a JVM, and really it's just the operating system that loads your application and instructs the hardware. That's it. There is no middle step, which in general is the JVM, right? The JVM has been removed from the equation, so the execution time of your application is very fast. So I hope you enjoyed this lecture. Please stay tuned, and I'll see you in the next one.